we've talked about pure data objects, and we've talked about passing messages around, and we've talked about hot and cold inlets. One trap for young players with pure data is that the order in which things occur is often critical. And many strange things will occur in your patches if you don't really sort of get this. So what you need to do is understand the trigger object and learn to use that to control the order in which things happen in your patches. So let me open up a patch that demonstrates the problem and also shows you a bit of the solution. So over here we have an example of a dangerous patch. So let's just walk through it. What I want to happen is probably fairly obvious from looking at this. So if we work our way through the processing chain of pure data, we have a bang object up here that's connected to two separate messages, one with the value 1 in it, the other with the value 2. And these are hooked up into a plus object, and then we're displaying the output of that plus object up here. So what you would sort of expect, I guess, from looking at this is that when I click on the bang up here, it will send bangs to 1 and 2 that will feed it into the inlets of the plus object. The plus object will add them together, and then we'll get 3 down here. So let's click on here and see what happens. Uh-oh. We got 1. So there is something weird going on. You would think that 1 and 2 being fed into a plus object would give us 3 as a result. Unfortunately, it doesn't seem to work that way. So let's try and figure out what's going on. You'll see if I click up here again, now, the second time, we get the correct result. So what's going on? The problem is that pure data processes one chain of messages at a time. So what's going on here, when I click the bang object here, it's sending a bang message out, the first chain that I have connected to its outlet. So in this case it was the 1 message. So the bang triggers the 1 message, the 1 message continues down and is processed through the plus object, which is a +0 object by default. We haven't given it an argument to sort of set its state, so it's a +0. And then it displays the 1 in the outlet here. So it processes that complete chain, that sort of set of links first. Once it's done that, it goes back to the top again and processes the next chain of links. So in this case, because I hooked this object to the outlet second after I hooked up the 1 message, so this one comes second, so then that goes through, sends the 2 object message through into the cold inlet of the plus object, which if you remember doesn't trigger any output, just changes the state. So this is now a +2 object. But because we've already processed that chain with the 1 message first, through the +0, through the object when it was in the +0 state, we only got 1 the first time we did it. But as you can now sort of imagine, the second time we do it, we get the correct result because the plus object has had its state changed and it's now a +2 object. So how do we deal with this problem and make our patches reliable and sort of predictable? We use the trigger object. So what the trigger object does is it takes whatever comes in its inlet and sends it out its outlet in the order from right to left. So what we're saying here is we've got a trigger object, we're passing the arguments B and B to indicate that we're going to be sending out bang messages. So when we get a bang in here, the trigger object will first send a bang out its rightmost inlet. And I should say I can add more arguments. So if I need to send sort of 3 bangs or 4 bangs or 5 or 6 or 7, any number, I just keep adding B's to this argument list. So in this case we have 2 because we want to send 2 bangs out, 2 separate outlets. So we have a bang comes in the inlet, we send a bang out the rightmost inlet first, so that triggers the to message to be sent to the inlet, the cold inlet of the plus object, so that's now a +2. That's that chain finished. Then we go back up here, the bang comes out the first outlet, the leftmost outlet, which is actually the second one to be triggered, the leftmost outlet, which triggers the one message to be sent into the plus object. That's the hot inlet, so that will add 2 to the 1, and the output will be 3. So in this case, when I click up here in the bang box, we should get 3 the very first time. In other words, we should get what we would naively expect from this. And you can see that that did in fact work. So depending on the type that you're sending out, the trigger object you'll send, you can send, we've said we're sending out bangs, but you can also trigger floats and other types as well. But we'll get more into that sort of stuff a bit later. So the main thing is, with pure data, the order that things happen is often critical, and it's important for you to be on top of this. And when you're in any doubt about what order things are happening in, use the trigger object to make it unambiguous. Okay, so you would have also seen that we can pass arguments into objects to set their state. So we could, if we're instantiating a plus object, we can pass in the number that we want to add to any inputs that come in the first inlet. Likewise with the metronome, before we said we wanted a delay of 500 milliseconds between the bang messages that are sent out the outlet of the metronome. And if we're using, say, a reverb object, we can pass in various parameters when we initialize that object to set up the style of the reverb we want. And you can usually, not always, but usually change the state of objects via messages as well. So we've been doing, in the past examples, we've changed the state of the plus object by passing in messages to the top right inlet. And you can do the same thing with the metro object if you want. You could pass a message in to its right inlet, and that will change it from a metro 500 to a metro 250, which means it's going to be outputting a bang 4 times a second rather than just twice. And you can do the same kind of thing with the reverb object here. In this case, we send these messages to the leftmost inlet, and we can set parameters like we can say, oh, you'd set the room size to 0.6, set the damping to 0.3. So you can check the documentation for every object to see exactly what the messages are that it responds to and what the parameters are to set it up. And I should also show you that if you right-click on almost any object in PD, with PD there's always a qualification. It's always like it almost always does this, or it usually does that. Well, usually when you right-click on an object, like I'm right-clicking on trigger here and click on help, PD will bring up some built-in help that describes how that object works, usually gives you an example of how to use it, and describes what arguments there are, if any, for that object. So just like processing, it has lots of good built-in documentation in most cases. So right-click on the plus object, you'll see examples of the various mathematical operators and things that are built into PD. So when you're creating a pure data patch, just like if you're creating a program in processing or any other programming language, you normally need some way to basically do kind of if-then statements. You know, if something occurs, then do something. If something is the case, you know, if the input from the user is greater than 10, then display the color red. If the user inputs a number that's less than 10, then you know, display the color yellow, that kind of stuff. And in PD, if you're used to sort of text-based programming, getting used to the way PD does this kind of thing can take a bit of adjustment. There are basically several ways to do it, a number of different objects, like select, route, and Moses. So let me show you some of those now. Let's just tidy up. So what you're usually doing in Pure Data when you're looking at this kind of stuff is you're usually kind of you're thinking of the flow of data through your patch. The flow of data sort of comes from top to bottom, unless you arrange your patch in a very odd way. Usually you arrange things so that the data is kind of flowing from top to bottom. So we have data flowing from these messages up here through the route object and then out down to these objects. And what you're doing when you use these kind of selector objects is you're sort of splitting that stream. So you're kind of looking at some numbers or some input in the route object or the Moses object, and you're saying, okay, if that input is a particular value or is in a particular range, then continue processing down this chain. If it has a different value, then process down another chain. So what we've got here is a route object, and we're passing the values 1, 2, and 10. That means when we get a 1 in its top left inlet, we send that output through the first outlet. If we get a 2 message in through the inlet, we'll send that to the second outlet. If we get a 10 message in, we'll send it through the third outlet. And if we get 100 in, or basically if we get any other number in apart from 1, 2, or 10, we'll send that out the fourth outlet. So it's a way of splitting a stream of numbers and processing them in different ways depending on what happens. So what we could have down here is a whole sequence of other objects that are linked to this bang message that might, I don't know, say adjust the volume of, adjust the parameters of a reverb object, depending on what messages come in up here. So let's see how that works. So you should see when I click on, say, 2, we should get a bang message coming out the second outlet. If I click on 1, we should get out the first outlet. 10 should take us to the third outlet. And 100 should send us out the fourth outlet because it's not 1, 2, or 10. And I've hooked that up to the inlet of a print object. So when I click on this, we should see 100 be printed out over here. And you can see that's the case. So this is kind of a way of saying if a value equals 1, then do this stuff. If a value equals 2, then do this stuff. If a value equals 10, do this stuff. If it's else, do all this stuff. So it's kind of like the equivalent of a numerical if statement, but in a visual programming style. So it does take a bit of getting used to. Moses is another similar object. Moses is so named because it splits a stream of numbers just like Moses parted the Red Sea apparently. So what you'll see here is if you send numbers that are less than 50 into the inlet of this Moses object, it will send those numbers out the leftmost outlet. Anything that is 50 or more will be sent out the right outlet. And you can see I've hooked these outlets up to print objects that will send the output into the window over here. So you can sort of see as I start scrolling this number up, all the numbers that are less than 50 are going to the less than 50 print object. If I scroll up and up and up and up, eventually I'll get to 50, and now we're seeing we're going out that right outlet and going to the second print object. If I go back down again to this. So this is a way of splitting a stream of numbers like a sort of a simplified if statement. You know, if x is less than some number, do this, else do something, do the other thing.